Welcome to this biochemistry lecture on fatty acid catabolism. It's also called beta oxidation. So again, we've talked about glycolysis right in the middle. This is where lipids, beta oxidation, where lipids enter into glycolysis and the citric acid cycle. So you can see on the left-hand side of this chart, the glycerol goes into glycolysis, fatty acids go through beta oxidation and into acetyl-CoA. This is as an introduction. Glucose generates about 186 kilocalories per mole, whereas if you take a palmitic acid, which is a very common lipid, you end up with 2,340 kilocalories per mole. So you end up with, about a little over twice or to 3 times the amount of energy generated per a little over 3 times the energy generated per gram. Okay, so the general idea is, here's beta oxidation cycle. You end up, this is a 5 enzyme catalyzed reaction. Basically, we're just going to cleave off the carbon atoms 2 at a time from the carboxyl end to the fatty acid. So, and then we have, this is a great chart, a reference chart to notice all of the reactants, products, enzymes that occur in this cycle. And the general idea that you want to get out of this is there's 5 steps, and it's a cycle. So the idea we're going to do is we're going to cleave off the glycerol, and then we're going to just eat up those fatty acid chains in the beta oxidation. The first thing we're going to talk about is, this is the beta oxidation step, which is the fatty acids. This is the first step. This reaction is the first step in this process. And in this reaction, the fatty acid is going to be activated by the conversion of an acyl-CoA. Activation is the equivalent of a hydrolysis of 2 high-energy phosphate anhydrides. So it's a very high-energy step. So basically, the fatty acid has your carboxyl group, and we're going to add on this sulfated CoA group in the hydroxyl instead of the hydroxyl. So it's a thiol-CoA, and you're going to spend 2 ATPs. So you take fatty acid plus a couple plus an ATP plus the CoA, thiolated CoA, and you're going to end up with an acyl-CoA that's thiolated plus an AMP plus 2 phosphate groups. The second step, we're going to have an oxidation by FAD in the carbon-carbon single bond. We're going to make it a carbon-carbon double bond. So what you're going to end up with is a trans-enoyl-CoA. This is done by an acyl-CoA dehydrogenase. So that's the second step. So basically, we're going to make this double bond, and reaction 3 is we're going to do a hydration reaction of that carbon double bond to give a 2' alcohol. That's done by in 2 steps, an enol-CoA hydratase, where we add water, and then we end up with an oxygen group, and then we're going to do a beta hydroxyl acyl-CoA dehydrogenase, and that is going to convert that hydroxyl group into a carbon oxygen double bond. That was reaction 4. Reaction 5, we're going to cleave that carbon chain by a molecule of thiolated CoA using a thiolase, and we end up with an acyl-CoA and an acetyl-CoA. So we end up with 2 molecules, and this is where we then start chopping things off. So the cycle then of reaction is then repeated on the shortened fatty acid chain and continues until the entire fatty acid cycle is degraded to acetyl-CoA. So we just keep going down that pathway. If it's a 16 carbon fatty acid, you're going to do it 7 times. So because you're taking off 2 at a time, and then the last one where you have 4, you're just dividing that in 2. So you have, it's basically half divided by 2 number of steps that you're going to go through this beta. That will be an exam question, just so you know. If you have an 18, it's 8 times that this is repeated. It's half the number of times since we take off 2. I'll repeat myself. If it's 18, it's 8. So half of them, right? You're chopping off 2 at a time until you get to the last one where you have 4. When you chop that last one in half, you don't actually have to chop it again because you're dividing it in half. So it's already got 2. So this is when we end up with an acetyl-CoA, and then that feeds into the citric acid cycle. Energy yield is we have on the first step of activation, we end up with a -2. When we go into oxidation in the citric acid cycle, we get 8 times, so we get 16 ATP out of that. Oxidation of a hydroxyl acyl-CoA to a keto acyl-CoA produces NADH plus a proton. That gives you 24 ATP, and oxidation of acetyl-CoA by the common metabolic pathway gives you, it happens 9 times, 108. So the total is 146 ATP molecules for a C18 fatty acid. You'll want to know this. That's the process. I think we've talked about how glycerol, actually all you're doing in the first step is removing the glycerol, so that's part of the process. Thanks for listening, and we will see you in the next slide.